In the last lecture, we started the detailed discussion about energy resources, why there's a need of energy resources for developing countries like India, and why the developed countries are basically energy sufficient and they are developed nations because of the reasons I have shared with you all of. Okay. So I think so these things I have covered in the last class. So I was here only, I think so. So I was discussing once we're going to have a, you know, the classification of energy resources. Basically, you're talking about non-commercial and commercial sources of energy. And basically, we are concerned about the conventional resources and non-conventional sources of energy. Okay, non-conventional means non-renewable sources, and non-conventional means renewable sources of energy. And if you talk about what I discussed with you last time and what I'm going to discuss right today also, the conventional sources of energy that is non-renewable sources of energy are basically fossil fuels. Okay, fossil fuels, coal, petroleum, all these kind of products. Okay, and basically when talking about we're talking about non-conventional sources of energy. They are solar, geothermal, wind, and tidal waves. Okay. So once we're talking about conventional energy resources, I think so there's no need of discussion like we have coal, petroleum, natural gas, and nuclear materials. So I will be touching these parts, not giving you exact details, and just to give the overview before actually moving to the this particular renewable sources of energy like solar, wind, all things in detail, biomass in detail. Okay, so I will be touching all these particular conventional sources in a bit, overview, that is coal, petroleum, natural gas, and nuclear. And mind it, again, I'm repeating that this is just to give you the glimpses of what we are having and why we are shifting towards these kind of resources. And you will not be getting any question what I'm showing, what I'm discussing, like what I'm discussing in general about coal or kind of stuff. You will getting a good questions in biomass, good questions in solar, good questions in wind, and numericals accordingly in this kind of material. So as I told you, there are some basic glimpses you can go through. So there are very less coal reserves in the country. And if you see the national demand, is huge and domestic production is very less. And that means you are having a deficit of 190 tons. It's more than that, basically. It's old data. It's more than that. 190 tons of deficit is there. And therefore, we are depending upon the imports. And if you remember, the last lecture I told you the 70% of the Indian economy goes for the import of energy resources. And the coal is one of that. And if you see that coal consumption pattern, 60% of our power sector is dependent upon coal. That's a major concern. Why is a major concern? You know very well what I'm talking about. If your thermal power plants, your power sector plants, where the electricity is being produced, is mostly dependent upon coal, and that too with not a good quality coal, inferior quality of coal, which I'm discussing later on. And there's a lot of concern that if your most of the power generation is dependent upon coal, and that coal is too of an inferior quality, there's a lot of emission of CO and CO2 that is really contributing to the okay is this kind of global warming. Okay, hold on for 1 minute. And sorry for the interruption. So what I was discussing this thing, okay. The major concern is that like in India, a developing country, you have major sector, that is that power sector is totally dependent on coal. Okay, whereas in other countries, I will be discussing now in the coming slides, they are mostly dependent upon nuclear or some other renewable sources of energy. So this means they are releasing a minimum amount of CO2. That's why their environment is too clean, their atmosphere is too clean, and there's the least impact of global warming. And that's why those countries are very clean in terms of all kind of stuff. Okay. So once we're discussing type of coals, you have anthracite, you have anthracite, you have bituminous, subbituminous, and lignite coal. So what are these kind of coals? You go through this once. Okay, I'm not going to give you detail better. So it's not like that I'm going to ask these questions. What do you mean by anthracite coal? What do you mean by bituminous coal? I'm not going to ask these kind of questions. Just this is for your information, nothing else. Okay. But if you want to have overview what I'm going to discuss, what I'm discussing in this all kind of this thing, the overview is being given in the table over. And if you see different kind of coals, anthracite, bituminous, subbituminous, and lignite coal, and see this fixed carb is a content which is actually governing the heat capacity or calorific value or heat content of the waste. If the fixed carbon is high, then more heat is generated. More heat generated means more output will be there. And if you see the lignite, it's having a minimum fixed carbon content. And if you see the ash content, that is unrequired, that is not required, more than 10%, 10 to 50%, sorry, range. What is ash? Bottom ash. So again, I told you, in solid waste management, the bottom ash which is being left in these kind of plants is being fed to the landfills. So landfill load increases. When the landfill load increases, so by default you have a problem, like when you have less fixed carbon, there's less heat generated, CO2 generation is high, gases emission is high, and bottom ash, solid waste generation is high. This means you are having a big problem at everywhere. And India, the major problem is, if the power sector is mostly dependent upon coal, and we are having a coal which is a major supply is a lignite. So now see, your process is less efficient, number one. Your technology is less efficient, number two. Number three, the technology which is less efficient is processing a coal which is of inferior quality, that is lignite. Okay, and see the heat content, that BTU per pound, that is very less, 4,000 to 800 only, that is about BTU per pound. Okay, so this is again a concern, Bache. So when you have anthracite coal, when you have bituminous coal, these coals are very costly, very costly. Okay, the cost of production goes high. And if you see the heat content, see this huge heat content is there, and see the fixed carbon over here. Anthracite is the number one, that is 85 to 98%. This means it's equivalent to what I want to burn 3 times. So it is 3 times the lignite. So this is the concern when you're talking about these kind of coals. So in India, the major concern is major power sectors is power sector is majorly dependent upon the coal. So again, the coal is a inferior quality. So this means you have a double blow everywhere. You are dependent on coal, that is huge generation of CO2, CO, huge generation of bottom ash, and effect on environment. So this is a concern I'm talking about. Okay, and again you have okay. Again, you have this kind of problems I'm talking about. Coal sector, basically you talking about coal sector. Okay. Yes, so you have first of problem is exploration, mining, preparation, sorting, cleaning. You have every problem related to the basically when you're talking about other coal technologies which are being applicable, will tell you get the final coal which is being fed to this power generation house. Okay. Now this is basically where technology is available when you have the coal sector. So either you divert the coal to the combustion. This you have a boilers, fine, big powerhouse boilers are there in which you have a direct combustion of the coal. When you have direct combustion of the coal, you have a heat generated, the heat is taken out, that heat is being taken out to convert water to steam, and the steam is used to run turbine. Accordingly, I told you heating, work, electrical energy is being used for that. And you can use coal directly for liquefaction. I told you, if you remember the last few lectures in solid waste management. So high temperature, high pressure phenomena is required when you directly convert this to liquefaction. And this will ultimately produce the liquid fuels. And liquid fuels are directly fed to the transport industry and other transport and industries, and for fuel, for as a, use as a fuel. And it can be used as a gas also. The coal is directly converted to gas also. Okay, so this is going to produce a gaseous fuel, and gaseous fuel again are used in industry, all kind of applications. Okay, in transport and chemicals, they are chemical industry, they are going to use as a fuel. And when you see the Indian contest bit, I told you, if you remember, I told you, and this is a picture actually showing 60% of Indian electricity generation capacity comes from the thermal power plants, and with 85% of the country thermal power generation being coal based. It's a huge concern, but you can see this, we have a maximum part is coming from the coal. And once we're talking about renewable sources of energy, this is something we want to concentrate, where the least CO2 generation or global warming is here, least impact on the environment. You have a very less percent, 3%. But now India is getting up with time to shift to renewable sources of energy, wind, specifically solar. Okay. And that's why the role of engineers come into picture, like you persons, mechanical engineers, development of solar panels, all kind of stuff, effective structures. बेटा वही बात आती है, कि एक इंजीनियर्स का क्या रोल है. ठीक है, तो यहाँ पे अपने वही बात हो रही है कि आप मैकेनिकल इंजीनियर्स हो, तो आपका रोल डिफाइन नहीं है क्या करना है आपको. जब मैं बाहरी कंट्री की बात कर रहा हूँ, चाइनीज, जापान एंड दिस काइंड ऑफ, साउथ कोरिया, दिस काइंड ऑफ कंट्रीज, ये इंजीनियरिंग ब्रांच को इतना सिंप्लीफाई कर रखा है उन्होंने, उनको उनका ड्रीम बता रखा क्या है, वाइल टेकिंग टू कंसिडरेशन कि उनका जो नेशनल इशू है. मैं एग्जांपल देता हूँ आपको. पैनल्स बना रहे हैं और सोलर पैनल बना रहे हैं, और उसमें मैकेनिकल इंजीनियर क्या कर रहे हैं, मैकेनिकल इंजीनियर विद द हेल्प ऑफ इलेक्ट्रॉनिक्स इंजीनियर्स, हमारे इंजीनियर्स, दे आर मेकिंग पर्टिकुलर पैनल्स कि वो शाम को इन द इवनिंग में सनलाइट इज नॉट देयर, वो फोल्ड हो जाती है. अब क्यों फोल्ड करना है मेरे को बेटा, सबसे बड़ी बात है कि अब सोलर पैनल्स का सबसे बड़ा कंस्ट्रेंट पीछे में आया कि लैंड रिक्वायरमेंट इज वेरी हाई. और जब पंजाब की बात आई, हरियाणा की बात आई बेटा, तो पंजाब हरियाणा का सबसे बड़ा कंस्ट्रेंट है कि पंजाब और हरियाणा और यूपी, वी हैव अ वेरी गुड सनशाइन, नंबर वन, सो सोलर एनर्जी कैन बी हार्नेस्ड. बट जब हम बात आई, उस चीज की बात आई अभी हम, ठीक है, द लैंड इज वेरी फर्टाइल, land is very fertile. So when the land is very fertile, you can use this land for solar panels. तभी आपने देखा होगा कि बहुत जगह पे पंजाब में रिवर्स के सेंटर में ये पैनल लगाए हैं. And if some person is from Ludhiana, and they can correct me, or they can tell other students also, when we turn from the Mukeria towards Ludhiana by this way, and there's a the river, the small the canal is there, और कैनाल के सेंटर में पिलर्स इरेक्ट करके उन्होंने बहुत बड़े बड़े पैनल लगाए हुए हैं. ठीक है, दैट्स अ गुड आइडिया. यू नीड नॉट टू हैव अ गुड ग्राउंड स्पेस नहीं है आपके पास. ठीक है, और ये आपका रिवर है, रिवर में पिलर इरेक्ट करके यहाँ पे उन्होंने पैनल लगा रखे हैं. उसके मल्टीपल यूज क्या हो गया, एक तो लैंड रिक्वायर्ड नहीं हो गई. सेकंड, दिस पैनल्स आर गोइंग टू इफेक्ट सो रिड्यूस द इवेपोरेशन लॉसेस. ये रिवर ओपन है, सॉरी ये कैनाल ओपन है, और इवेपोरेशन लॉसेस बहुत ज्यादा हो रही हैं. सो यू कैन रियली अवॉइड द इवेपोरेशन लॉसेस बाय covering this with the solar panels. So it's a very good idea, wonderful idea. I have seen that. Okay. So वही बात मैं बात कर रहा हूँ कि I have seen that some documentary in South Korea and Japanese and China, what they are making a totally foldable panels. ठीक है जी, जैसे काम हुआ, you can fold it out, automatically fold. It's a wonderful, beta, this is a wonderful idea they are working on. It's like they are working on every aspect कि इसका solution है तो कैसा है. Okay. I think so. I have explained enough. I think so. And role of you engineers also explained. Okay. The second is the petroleum. Okay. I think so. No need of discussing this thing in detail once I'm talking about petroleum, particular resources. Okay. So petroleum, basically you have it's a fossil fuel. It's found by decomposition of bacterial anaerobic decomposition reactions for buried vegetation for mass, this animal masses for number of years, several million centuries. Okay. So you need to have these kind of things once you have exploration of production processes. That is, you need to have geological surveys, exploration of the oil and natural gas, drilling, production, storage, distribution. There are so many aspects are being associated with this kind of petroleum resources. And I think so, if you see the petroleum resources, need not tell you, you have a different compositions according to the requirements. You have naphtha, you have fuel oil, you have asphalt, you have petrol, you have diesel, depending on a fractionation column. I think so you have must have read at what level what you are getting. At C6 and C12 we are getting petrol, C6 C22 we are getting petrol, diesel or kerosene, and further you're getting naphtha, fuel oil. So it all depends upon where you have your fractions. So this is overall picture where I think so you can go through, bache, all of you. Okay, I'm not going to discuss where are the basically major oil fields in India. Okay, basically when talk about the major oil field is which greatest output is Bombay High, where they are using 4 lakh near about barrels per day, and that is 15 times amount produced by the next larger field. This means we don't have a second largest field like Bombay High to explore this petroleum. And that's why we are basically very much worried about the shortage of this kind of resource. Okay. So if you see this, and this is natural gas, but again, this is again very clean fuel, but again the availability also natural gas तभी मिलेगी जब आपको पता ही natural gas कब निकलती है. When you have that this petroleum resources, the first comes is natural gas. Okay, this, the largest component of natural gas is always a methane, you know very well. Okay, so it has a lot of power. It is well proven that it's a lot of power. It has a lot of heat content also. Okay, so you can use this as a clean fossil fuel. So when it burns, natural gas produces mostly carbon dioxide, water vapor, and small amount of nitrogen oxide. But the concern is again the availability. See this, what is the kind of availability? Okay, so you have a deficit, no doubt. Okay, so if you have a deficit, like you have a gap of this much of per day, 55. Okay, so when this gap is there, you need to import the natural gas. When you need to import the natural gas, there's a lot of economies required. So a lot of economies involved. When a lot of economies involved, no doubt what I'm discussing right now with you. India is now facing a huge crunch towards availability of these kind of resources for making fulfill their needs. And that's why we are looking after all the engineers to look out for the alternate source of energy, number one. And they are looking after mechanical engineers to develop engines so that the engines can have better efficiency, means they consume less particular this kind of fuels and give more output. And moreover, they are looking after the mechanical or electronics engineers I told you last time, to build engines which can really take up the blended fuels to higher extent. And if they can really take the fuel to a higher extent, the blended petrol or blended diesel, this means blended diesel means biodiesel, biopetrol that is being produced from the edible or non-edible oils, and it's being mixed with the conventional. So अगर ये हम ये करते हैं, no doubt हमारा जो active exploration है, main resource है, वो कम हो जाएगा. So we always have a less exploration at the active resource. So क्यों आपके पास alternate आ गया आपके पास, है ना? तो ये चीजें हैं जो मैं बात कर रहा हूँ. So this is something I want. See this. So this is a final electrical energy obtained, EE. This is final electrical obtained at the receiving end. That is EI into N. What is EI? EI is the amount of energy released from the coal combustion in joules. Eta is the efficiency. Now, once you talk about India or developing country, you have a problem here also, here also. What is here, beta? EI. EI is the amount of energy released from the coal. So once you have a low quality coal, inferior quality coal, where the carbon content is very less, then by default EI is very less, because the amount of energy released per kg per ton of coal should be very less when you're talking about lignite coal. The carbon content is very high, ash content is very high. Sorry, carbon content is very less and ash content is very high. Okay, so in that case, I can say reasonably EI is very less. And second is ETA, this efficiency of conversion, energy conversion process. Now, same thing here. ETA is very less. Why? Because we have not up-to-date technologies. We have not some sophisticated technologies with a very good efficiency of conversion of this uh, this energy to the electrical energy. So huge losses are there. So ETA is also less. And if two terms are less, their product is always less. Then EI is less. So in addition to this, there's a major problem in India. Why I'm saying India? Because other countries, they have, like these kind of wonderful ideas. Now, see, you are at Patiala, suppose, or you are at somewhere at a place, and electricity is being produced in Patiala, suppose. We have head office in Patiala, electricity board, and we have to give supply to Ropar or some other section, Mohali or some other, fine. Then we have to have a transmission lines, distribution lines. And you must have seen in the field high tension wires, and these high tension wires, they are carrying a high voltage currents, high voltage. So when this high voltage, high current is there, no doubt you have huge heat is being involved and huge losses are there, and these are called transmission losses. These are called transmission losses. And see this, when you talk about EF is the actually final energy that is being received at the customer end user. That is EE. That EE is basically, no doubt, final energy obtained from the coal or from the source into L1 minus LTD. What is LTD? LTD is a fraction of electricity lost. So if the fraction of electricity loss is high, this value is high, difference is less, then multiply with EE, it should be less. So final electricity that is being reaching to the end user is very less. So that's why the electrical engineers, all the engineers will come into play. They need to work on the idea how to minimize the transmission and distribution losses. Okay, so if you put the value of EE from here to here, you will get the final expression like this. Hence, the relation between the initial energy obtained in the coal, contained in the coal, sorry, and the final energy that is being received at the user end is governed by this equation. EI, ETA 1 minus LTD. So you have to work on each and every factor, because the EI also. EI, how you work it, how you can work it for EI, you must have a better quality coal. Number one. Number two, ETA. Must design the process, must design the machine, must design the machinery like that the conversion is always high. When the conversion is always high, losses are less, ETA is going up. Then design the system in such a way that transmission and distribution losses are minimum. देखो लॉसेस तो होंगी बता, इलेक्ट्रिसिटी लेके जानी है तो वायर्स के थ्रू ही लेके जानी है, हाई टेंशन वायर्स के थ्रू लेके जानी है, ठीक है. High tension wire means carrying these kind of current means loss of energy. But how you are going to use your mind, how you're going to use the technology so that the transmission losses are less. When transmission losses are less, this product is high. When this product is high, by default, this product is high, then EF is high. That we always want. Okay. So if you have any doubt, you can really on ask me. Okay. Then I'll talk about something about nuclear energy, beta, to give you just a glimpse of what is exactly there in the nuclear energy. Okay. देख लो इसको एक बार बेटा, न्यूक्लियर एनर्जी को. ठीक है जी, क्या है आपको पता है मेरे ख्याल से इसके बारे में, आपको यू नो वेरी वेल. गो थ्रू दिस बेटा. So nuclear energy is basically, you know very well, beta, the mostly the countries with the good uranium fuel, the reserves of fuel, they are going for nuclear energy. Although recent years they signed a treaty to ban all kind of nuclear activities, even nuclear production also. So that's why they are slowly and slowly shifting towards the renewable sources of energy. Okay, so basically when you talk about nuclear energy, it is either fission or fusion. Okay, mostly the reactor which are being designed on the basis of fission reaction, where the neutron strikes the uranium or some radioactive material, it's going to generate three neutrons and some smaller particular radioactive atoms. Then further neutrons will be available, make them available to strike these particular kind of smaller neutron nucleuses. So this chain will continue. Once this chain will continue, and no doubt lot of heat is being generated, because this is an extremely exothermic reaction. Okay, so there's some information written over here, you can go through it better. And I again telling you, you will not get any question out of like what is a nuclear reactor, what do you mean by this, what do you mean by this. This is just to give the basic introduction about what is energy scenario, what is the energy aspect, and how we are moving towards what is actually being required in India. Okay, so first commercial scale nuclear power plant 180 megawatt capacity went into operation 1956. See this in England. Why they are shifting on this? Because they have surplus nuclear fuel, number one. India, why they are not going for nuclear? Number one, technologically sound nahi hai, number one. Number two, they don't have a nuclear reserves. They have to import nuclear, and uske baad bahut pange hain, safety concerns. You know very well safety concerns. Although the electricity or energy that is being produced from the nuclear fuel is associated with the zero supply of CO2. That is minimum to minimum supply of CO2, I can say. Okay. So this is basically an overview of what I'm discussing. There are so many particular power plant, power reactors in world. Okay. And 50 more are under construction, but right now what they sign a treaty, they are percent जो बन गए उसके बाद कोई नहीं बनेगा इसके लिए. Okay. तो यू नो दिस इज अ बेसिक थिंग बेटा, पढ़ लेना इसको एक बार. अब इसमें क्या है बेटा, आपका ये कोर है ना, इसमें फ्यूल रोड्स हैं. फ्यूल रोड किसकी है? आपकी आपकी यूरेनियम की या रेडियोएक्टिव मटेरियल की. और सबसे बड़ा इंपॉर्टेंट रोल है कंट्रोल रोड्स का. अब कंट्रोल रोड्स क्या होती हैं बेटा? कंट्रोल रोड्स होती हैं किसी मटेरियल की बनी होती है जो न्यूट्रन को ऑब्जॉर्व करती है. ठीक है, क्यों? बिकॉज आपके यहाँ पे जैसे रिएक्शन शुरू होता है फ्यूजन का, 3 न्यूट्रॉन्स जनरेट होते हैं. तो कंट्रोल रोड का जो पर्पस है वो 2 न्यूट्रॉन को ऑब्जॉर्व कर लेता है, एंड इट्स गोइंग टू लेफ्ट विद ओनली 1 न्यूट्रॉन. This neutron again strikes the nuclear material, start producing 3. And control rods, their position up and down is controlled in such a way that 2 neutrons are immediately consumed, trapped, and only 1 is being left. That 1 is again set for the further nuclear reactions. So in this process, I think for every kind of single fusion reaction, a lot of heat is being generated. And this lot of heat which we are generating is being taken out, or sometimes vessel is there inside, sometimes vessel is outside, to convert water to steam, high pressure steam. That high pressure steam is being taken out to run a turbine, and accordingly gases are being released. Okay, and the cool water which is being condensed over here again being sucked back. Okay. तो ये अलग अलग तरह के बेटा रिएक्टर हैं, इसको गो थ्रू होना बेटा. ये है जो रिएक्टर, दिस इज प्रेशराइज्ड वाटर रिएक्टर. अब इसमें क्या करते हैं हम क्या करते हैं, जो आपका कोर है जहां पे आपका मेन आपका रिएक्शन होना है अपना न्यूट्रॉन के साथ, we keep the reactor outside, the heat exchanger outside. The water in the core heated up to 315 degrees centigrade. It's a huge temperature, but it's not into steam, क्योंकि उसको हम अंडर प्रेशर रखते हैं, अंडर प्रेशर हाई प्रेशर रखते हैं. तो हाई प्रेशर की वजह से क्या होता है बेटा, स्टीम में कन्वर्ट नहीं होगा. Movement is being taken out in the heat exchanger, expansion will be there. Once the expansion will be there, it will be immediately convert to the flash vapors, high pressure steam. I can say. And the high pressure steam is going to heat up the water, and the water is being converted to steam, and steam is taken out and actually being produced. Okay. So this is the overall discussion when talking about for nuclear. You can go through beta. So these are the different kind of Tarapur, Gaiga, Madras, Navara, tractor, and sun tractors. The discussion is there. Just go through it. This is for your information only, beta. No need of cramming all these kind of things. Okay, so you go through this, beta. All of you. I think so. I should stop here. I think so. So this nuclear I have covered enough. I think so. Just go through it, beta. Basic ideas. These slides I will be sharing very soon on the LMS. And meantime, I think so. I told you if I not shared with you, I want to tell you the slides related to the numericals of air pollution and solid waste management are already uploaded in the on the LMS. Number one. Number two, I have also uploaded one tute sheet on stoichiometry, material energy balance, or air pollution nearby on LMS also. These are short ones. So this is for your practice only. Please you go and practice these kind of numericals also. All of you. Okay. So I think so. You can go through this, but all of you. I think so. I should stop here. I think so. Okay.